For the next example, we have this differential equation. So first, let's write this differential equation in its standard form. We have y double prime as 9y equal to 1/4 cosecant dx. Now getting the auxiliary equation, we have m squared plus 9 equal to 0. So our roots m1, m2 is equivalent to plus minus di. So our complementary solution equivalent to c1 cosine of dx plus c2 sine of dx. So our particular solution equivalent to q1 cosine of dx plus q2 sine of. So this is our y1, our y2, and this is our f of x. Getting w, have cosine of 3x have sine of dx. First derivative of the first row, we have negative 3 sine of 3x have 3 cosine of. The determinant of this matrix is equivalent to 3. So w1 equivalent to 0, and our f of x is 1/4 cosecant of 3x of sine of 3x, then 3 cosine of 3x. We have 0 minus sine of 3x times 1/4 of 1/4 times cosecant of 3x. So cosecant, just the reciprocal of sine, we have negative 1/4. For w2, that's equivalent to cosine of 3x, and we have negative sine 3x 0 1/4 cosecant of 3x. This is equivalent to 1/4 cosine of 3x over sine of 3x. So our u1 prime is equivalent to w1 over w equal to negative 1 over 12. And our u2 prime equivalent to u2 over w equal to 1 over 12 cosine of 3x over sine of 3x. So integrating u1 prime and u2 prime, we have u1 is just equivalent to negative 1 over 12 x. Then our u2 have 1 over 12 integral of cosine 3x over sine of 3x dx. Let u equivalent to sine of 3x. So our du equivalent to 3 cosine of 3x dx. We have our u2 equivalent to 1 over 36 integral of du over u. We have 1 over 36 times ln of sine of 3x. So our general equation equivalent to yc plus yp. We have our general equation. Our general solution is just equivalent to c1 cosine of 3x plus c2 sine of 3x minus 1 over 12 x cosine of 3x plus 1 over 36 sine of 3x times ln of sine. So summarizing the method of the variation of parameters. So it is not a good idea to memorize formulas, but instead we need to understand the procedure. However, the procedure is too long and complicated to use each time. So what we need to do in order for us to solve a second order differential equation of this form, first is we need to find the complementary function y of c is equal to c1 y1 plus c2 y2. And then find the Wronskian of y1 of x and y2 of x. And third, put the equation in its standard form to find f of x. So this differential equation. And then find u1 and u2 by integrating this equation and this equation respectively. And then lastly, our yp is equivalent to u1 y1 plus u2 y2. Then our general equation is yc plus yp. Now for higher order differential equations using variation of parameters, so for example, if we have this higher order differential equation of this form of order n, so we can find a complementary function y of c of this form. So we have c1 y1 plus c2 y2 up to cn yn. So our particular solution is equivalent to this equation. We have u1 of x, y1 of x plus u2 of x and times y1, y2 of x plus up to un of x times yn of x. Now if we have this particular solution, we will arrive with this n number of differential equation. So our uk of prime is just equivalent to wk over w, meaning our w just equivalent to y1 y2 up to yn. And also we have y1 prime, y2 prime, yn prime is up to y1 n, y2 n, then we have yn of n.